boys and girls. Hi Varsha and Vidya. In the last presentations, you have understood the operation of Bpsk and Qpsk, and in all wireless communication, default modulation is Bpsk. But in your syllabus, binary phase shift keying is also included, although it is rarely used. I told you in the very beginning that a variation of it, that is a variant of that is MSK is still be used in modems, but Bfsk is rarely used. But since it is included in your syllabus, let me start with that presentation. Here the objectives are you will learn the mathematical model of Bfsk, and you will understand the Bfsk signal constellation, and you will derive and understand the probability of error for binary phase shift keying. Here in Bfsk, logic 0 is when logic 0 arrives, we transmit a sinusoid at say frequency f1, and logic 1 we transmit another frequency say f2. If these f1 and f2 are harmonics, then you can achieve almost a continuous phase Bfsk. So the mathematical model of Bfsk is SIT equal to root of 2 EB by T cos 2 pi Fi T. It is not TB, it is T. I took as T throughout. This is one bit interval capital T, where the frequency Fi is some NC plus I by T, where NC is some integer. And I is from 1 to 2, I is 1 to 2, that is S1T and S2T, corresponding to the bits 0 and 1. Now when you come to the Bfsk signal constellation, the orthonormal basis function is phi it, that is root of 2 by t cos 2 pi Fi t, because if you go back to this equation, you can, if you take out this root EB, it becomes a root of 2 by t cos 2 pi Fi t. And it is nothing but root EB into phi it. Now I need to find the vector space corresponding to this signal SIT, which is nothing but Sij. How do I find the vector space? That is, I have to take the dot product to know the contributions in phi 1 axis and phi 2 axis. So this dot product is realized by this integral 0 to t SIT here phi jt. So this is integral 0 to t root of 2 EB by t cos 2 pi Fit into root of 2 by t cos 2 pi fjt dt. Now this integral, if you look closely, when I equal to j, it becomes this function becomes root EB into t by 2 by t into cos square Fit, and the cos square Fit time can be written as 1 plus cos 4 pi Fit, which on integration becomes that cos 4 pi Fit becomes a sine 4 pi Ft, which is an even multiple of sine. Integrated over 0 to t, it becomes a integration over cos 4 pi, that becomes a sine 4 pi into something, which is a 0. So that half becomes half into t. So ultimately this integral becomes t by 2, which cancels 2 by t, and only a root EB remains. For I equal to j, it is root EB, because it's a cos square Fit, which on integration becomes a t by 2. So when I not equal to j, these are cos cos 2 pi f1t into cos 2 pi f2t, which becomes a cos 2 pi into f1 plus f2t plus cos 2 pi into f1 minus f2t, which on integration becomes two sinusoids, which on over the limit from 0 to t becomes a 0. So Sij is root EB for I equal to j and 0 for I less than j, I not equal to j. Now these signal vectors can be written as S1, that is equal to root EB 0, and this is 0 root EB, because when this is S1 corresponding to, so this is S11 and this is S12, and this is because this S11 for I equal to j, it is a root EB. For I not equal to j, it says 1 2, it is a 0, and this is for the row or column 2. So this is S21, which is 0 because I not equal to j, and this is S22. So this is for I equal to j, so it is root EB. So this S1 and S2 I can plot on the thing. So this is equivalent to this S1 is equal to root EB into phi 1t plus 0, and this S2 is 0 into phi 1t plus root EB into phi 2. This is variation in phi 1 and phi 2 axis. So if I plot these vectors S1 and S2, it will look like this. So here this is a phi 1 axis, that is root of 2 by t cos 2 by f1t, and this is phi 2, that is root of 2 by t cos 2 by f2t. So this point is a S1, that is root EB 0, and this is a point 0 root EB. So that distance between this is root of 2 EB. Okay, this distance between the two signals is root of 2 EB by Pythagoras theorem. Now I can compute the probability of error with the self-same equation. P is QD by 2 sigma, and this D is root of 2 EB divided by 2 root n naught by 2, which on cancellation this becomes Q of root EB by n naught, which is nothing but half error function complement root of EB by 2 n naught. This is Q root EB by n naught. This becomes half error function complement root of EB by 2 n naught. So this is a probability of error for a Bfsk system. Now coming to the end of the presentation, now you understood the mathematical model of Bfsk, and you understood the Bfsk signal constellation, and you derived and understood the probability of error for Bfsk. And that's the end.